So I got this awesome little drone. It's a Phantom 3 Professional, and I flew it around a few times and it was really cool. Got some great footage out of it, 4K footage and all that sort of stuff. And then I completely ballsed up the landing and it came down, and then I did the wrong thing with the controls. It flipped up like that on the gravel and wouldn't turn off and started digging into the ground. The aftermath of all of that is these motors are quite open and exposed. Oh yeah! That's gravel. Oh, that one's... Oh, that's awesome. That one's fine. Oh, same with that one. So clearly these two took the brunt. So today's job is stripping down gravel falling out of it. Today's job is stripping down this body. I've got a spare body here, and we're going to replace the motors and put all of the electronics, camera, GPS, sonar, all of that sort of stuff into this one. So apparently it's a 9 out of 10 for difficulty according to YouTube's. So yeah, let's get stuck into it and see if we can actually do it without breaking it.
And many of them are standing straight, refusing to bend, defying the terrible weather. Note that once again in time, a man named King of Babylon is on the rise. Let's hope we'll get through. One step wrong and he will fall. We don't think he will dance at all. No more invites to the ball. When he's back down underground, we will all be singing songs.
So I managed to get the drone back together, and I was really stoked the fact that, you know, I'd actually done something like this. It was quite complex. Put the battery in to see if it'll power up and everything, and start doing some initial tests, and the battery wouldn't fit. So I did some investigations. You have a look down here, so you can see this is where the battery goes in, and that's a little tab there. There's a little positive and negative, that's what powers up the battery, and also 4 little pins down the bottom here that obviously do controls and things like that inside the battery itself. For some reason, I didn't notice it when I put it together. You can see how it's on a weird angle. See that there? And then also sideways it sort of tips down a bit towards the back of the drone. I don't know why it's done this. I've screwed it up normally and it measures up really similar to the old body, but for some reason the heights of the 2 little posts that it's screwed to are different heights. So as a result, it's tipped it down in one angle. It's a pretty simple fix. I just need to adjust it and put a little spacer in there, which is all easy enough to do. But to do that, I have to strip the entire body back, take the circuit board out, take the engines out, completely strip it back down to its base level in order to do that. So although I've rebuilt it, I've now got to completely strip it and rebuild it again for one screw that I can't access unless I do that. So that's my plan, is this coming week, strip it down again now that I know what I'm doing, strip it down, rebuild it, and then go and do some test flights. G'day, welcome to Project Brepeg. My name's Damien. We're converting a sunken fishing trawler into a global expedition and research boat. Today, we're up on the wheelhouse. We're getting our stainless corners welded in. So I've given all of the paint a bit of a flapper off. It's all pretty clean, so we're just going to start tacking this together now. Okay, so let's weld that in. So this is what we're left with for now. The welds aren't the best welds in the world, but they'll certainly do. What we're going to do is that top bit there, and then that bottom bit you can sort of see there. We're going to trim those off, and you can, as you can see, if you look down the line of the wheelhouse, that stainless is pretty much in line with the rest of the roof, and that's why I wanted to sort of build it in bits like this rather than build the whole thing on the bench. Now that that corner's been welded together, it's blowing a gale. Well, it's not, but it's windy enough up the top here that I can't really weld. So I'm going to call welding off up the top here, done for the day. I've still got the other corner to do on that side of the wheelhouse over there. But yeah, we're just not going to bother today. It's just way too windy to be able to get decent welds. I'm getting a wee bit of porosity in these welds and stuff, and it's pretty hard to try and stop that. Yeah, so we'll get on with something else. We've got Jess's Mac hinge to build. While I'm up on the wheelhouse, I thought I'd show you this. My mate Malcolm's Trimarine. It's a 27 metre wave piercer Trimarine. He's just got it all anti-fouled. He did that in the last, I don't know, week or two, something like that. So can't be too far off from launching, so that'll be pretty cool to see. So when I was at the top on the wheelhouse roof this morning, I was flappering off some of the paint and so that I can get a good weld going on. And it bit in. I don't know if you can see it, but it's all oblong shaped now. It's all ripped. All of the flapper pieces of sandpaper off one side. My grinder basically bit in and it flung out of my hands and it fired itself over the side of the boat. And I don't know, the cord on these are quite long, maybe, I don't know, good 12 feet long, something like that. So it swung 12 feet out from the side of the boat and then came back down and smashed into the side of the boat, and this has consequently stopped working. I think it's probably pulled a cable or something out from inside in here. I have to pull it apart to figure that out. Physically don't have the time to resolve it, so got another one. I needed to get another one anyway as a spare. I've only got one grinder, so if it stops working it was just too difficult to be able to do a lot. Now I've got one grinder and one that needs a bit of a repair going onto it, but yeah, we'll get in. So what we're going to do now, we are building a hinge for Jess's Mac. So this is, it's similar to a pantograph hinge. I don't know what the actual name is for this type of hinge, it's not exactly the same. So it swings down from the wall, so the screen stays up on top, hangs down like that when she's using it, and then comes back up onto the wall when it's finished, so it gets pushed out of the way. I'm building a whole thing out of aluminium. I want it quite light, but I also want it quite sturdy. So I've got some solid bar and some hollow tube that we're going to be using. So this is my plan. I'm basically going to do a solid bar across there and there, and then I'm going to do hollow bar up here and up there, and then a solid bar across there and across there. And these two frames, so because I'm going to have essentially a solid with two verticals welded to it, it's going to have sort of stiffness in that dimension, so it's not going to jiggle too much as opposed to having four individual arms. So that's my plan. So as far as the pivots point of view goes, it's basically two separate arms as opposed to four separate arms if we were to do two separate hinges. So that may make no sense right now, but it will absolutely make sense once I start putting this all together. So let's go and cut some aluminium out. I've got my two bits that I'm going to be using. So I've got that's hollow and that one there is solid. So what the plan is cut these to length. I'm actually going to drill down the center of these and put a pin in, and it's actually going to be a stainless pin, and that's what's going to be doing all of the pivoting as opposed to like a bolt or something along those lines. I'm not worried about stainless aluminium interacting with each other. It's going to be inside, so they're not going to be submerged in any seawater or anything like that. They will have atmospheric salt, but if that starts falling apart, then the rest of the boat is probably already rusted out. So I'm quite happy with that for now. So let's get into it. We'll start cutting up some aluminium.
I lose my breath whenever I see you. You stole my heart, what is it that you do? My life was great till you added colors. Like the moon needs the sun, we don't care about the others.
So in the end that I've just cut, because I don't have any sort of jigs to hold it perfectly level, what I do, get a piece of, in this case I'm using a bit of the solid, but just a bit of offcut the same size. It's sitting, I don't know if you can quite see it in between the tape, but it's basically sitting in the opposite end of the piece I just cut. And the reason I do that is because I can hold that vertical and get the other end in line with that T. I'll show you what I mean. So you can see the table's got 3 G clamps, one right at the back and then 2 up the front here, and they're in a position to basically hold the metal in the same spot every time. So that one at the back jams up against the pillar on the drill, and then these 2 here kind of form essentially just a left and a right chock, and then I've just got a, whatever those are, wood clamp holding the whole piece down. I've measured it out so that it's a bit hard to see. Let me just spin the drill away. So you can see there's a line on that aluminium just there. That's where I need a cut, so essentially the centre drill would have gone down there. I'm not using a centre drill at the moment, but that centre drill would have hit that black line. The reason why I've used the tape and the jig, you can see right down the end I've got that piece of taped aluminium sitting essentially vertically. It doesn't quite look it on the camera, but I have measured it vertically with a level and it's all good. That piece of steel behind it is actually on the boat and it's not vertical, so that kind of skews the view a bit. But basically what I do is with that piece down the end in a vertical position, I know that if I drill this here, I'm essentially going to duplicate the half cut that I've put at that end into this end here, and that way when I weld them all together it's not going to be a bit skew if on me.
Take me away, I want you for myself every single day. You set my world on fire. You set my world on.
So this is what you're left with. So you can sort of see you've got nice radiused out weld areas. They fit in nice and snug. You haven't got any silly bends and joins to try and do with a welder. You can just do a nice even curve all the way around. So that's one of the brackets laid out. So I'm going to basically build a duplicate of that. It's a slightly different size, but a duplicate of that, and then they fit one inside the other. In case you're wondering, I've got the drill press set so that it just gets close to the metal, the surface, but doesn't touch it. That way I know that I'm pretty much drilling all the way through, and I can just break the rest off just with a pair of pliers. It's going to be filled up with weld, so it doesn't have to be absolutely perfect to that area. You can sort of see there, it cuts through on one side, and you've got a slither left. You can just basically break it open, and then this bit here, it's normally a wee bit hot, but just get a spanner or something and you can just get in there and done. Right, 2 arms sorted. Okay, so now that we just got to basically measure these up, put them in position, tack them, and then finish them up with a good decent weld around all of the joins. But before we do that, we're going to start drilling these pins out. It's really important when you're building a boat, especially when you need to do a lot of welding, to find the windiest possible spot in Australia. Quite windy.
Very windy.
Yeah, so this is the initial sort of layout. Basically building 2 arms, like 2 sort of brackets, if that makes sense. And I'm going to use pins pushed into the end. I'll drill down these, drill in each end, push a pin halfway in, and that's what becomes the pivot. It's a solid stainless pin. I apologise if there's wind noise, it's absolutely blowing its guts off at the moment. So we've got our 4 pins, so I've got one in the drill here, but as you can see they're not cut perfectly square because they've just been lopped off with a grinder, but I want to make these nice and rounded and lovely. So what I'm going to do, put them in the drill like this, spin the drill, and then round it off with the grinder as I go. That's going to give me essentially the same ability that I'd have if I had a lathe. The drill's going to be my tiny little lathe. Righto, so this is why I wanted to do it this way. So at one end you've got a nice sort of rounded off end. It'll slide into a hole that I'm about to drill pretty easily, and at this end you've got a relatively flat end. It's not quite, it's slightly got a dimple in it, but it's basically a flat end with a chamfer on the edge, and this is going to be the pivoting end. So this is going to be inside some alloy, and this is going to be exposed. So my plan is to use these stainless pins as pivots. I'm going to basically, I don't know if you can quite see that little black mark, it's about 10 millimeters in from this end. I'm going to press this into a hole inside the aluminium. So these pieces of alloy, I'm going to drill a hole right down the center of that, and then I'm going to press it in so that the pin sticks out about that far. And basically what that's going to give me is a stainless pivot at the end. And it's going into a piece of stainless, so it's going to be stainless on stainless. The only bit of alloy contact is going to be the interference fit that's going to be inside this piece here. Another ½ inch to go. So I'm gonna probably glue that in because my interference didn't work. I was supposed to have 0.1 of a millimeter of interference fit, and I clearly do not have that. So this is what we're left with, basically a stainless pin inside the alloy, a bit like a rolling pin you can sort of think of it as. And these are going to be the pivots. So I don't have a lathe, so I'm going to try and fabricate one out of a battery drill and a grinder. Let's see how this goes. I'm calling that a success. So this is basically the structure. There's two of these, and the arm, the only difference between the two of them is the arms are 50mm shorter on one of them than the other, and that allows, as it comes down, for it to cock the screen in a particular angle. We have made this pivot. This is end here is the computer end, and this is slightly longer than this one here, and the reason being is because I want the bars to be able to go inside each other, so when it's pushed up tight against the wall, the bars are sort of able to overlap each other a wee bit. If I made them identical, I wouldn't be able to do that. It would always sort of sit out a wee bit. So the plan is to basically have a couple of bits of 6mm stainless like this. These are going to be bolted side by side like this on the ribs on the very front of the cabin, and there'll be a hole sort of top and bottom on either of these two pieces, and that's what these pivot pins here on the big bars. So on these two bars here, they'll basically be sitting in the holes sort of there and there, and it's the fact that these are bolted to the wall means that they can't go anywhere. So the hinge itself is able to fall apart until the stainless is bolted into the wall. Once it's bolted into the wall, it physically can't fall apart. So it might be a bit of a mission to get this sort of bolted up onto the wall when we finally make all of the parts, but once it is bolted up, it can't basically unassemble itself unless all of the bolts come loose on the stainless brackets on the ribs. So
no, I've finally figured something out. My hair has gone and it's going over to his. Look, he's growing his hair for the first time in 10 years or something. We'll see what it looks like. It'll be interesting. You're preparing for Antarctica already.
This is my woolen winter coat. If I leave it, I'll just let it like migrate down my head and get bush hair at this end as well.
So why are you using glue now?
Because some of my interference fit hasn't worked, and I just need these to be held in there. They don't have to be super strong, because they can't, once they're bolted together, they can't come out. It's just basically to hold it while I'm working everything. This is my interference fit on some of these ones that didn't work. Doesn't have to be mega strong, it just has to not fall out while I'm assembling it, so that's why I don't mind putting a bit of this goop in there. Springing out.
Could you lose it all the way down? No.
It's hydraulicking. God damn
Bang
it.
bang.
No.
Bang bang.
Look, I need to squeeze it. It's not letting the air out, so the air's compressing. Who didn't think about how that would
So
work?
basically when you say the interference fit's not right, it means you ground out too much.
Yeah.
Right.
I think what was happening is that I'm used to steel, where you can kind of drill a hole in it is the size that you drill it, and I think it heated the alloy up and it drilled, the alloy heated up and contracted in on the hole and out on the outside of the round, I'm guessing, and then as I drilled it took more material out than I was hoping, and consequently my 11.9mm drill drilled 12.1 or it's forming a really good seal. So basically the jaws are grabbing too far in the actual head of this and it's holding it out. So
Yeah, but what you're doing is the little thing, he's putting that in to hold it so he can roll it evenly.
yeah, I'm using the drill to basically give me spin of the alloy, and then I'm just cutting it with a grinder. The rolling pin, we're going to roll it along the bench, and then I'll just hold it really gently and cut it at this end. So you kind of got to use the pressure and the speed, so you need I didn't realise it until I did it, but you kind of need to do it yourself so you can control it both. So this is what you're left with. You got really lovely smooth cut at the end, just like what you'd have if you had a lathe, only this is a backyard lathe. pivot one. I've had a go at welding this alloy and it's clearly not welding very well. The weld, so I've got a 25mm solid round bar and I've got some hollow tubes, probably 3mm wall thickness, something like that, or 1/8 of an inch, something around that. The solid round bar is just basically losing the heat way too fast. I've tried heating it up with a map torch, like a little gas torch, to get it as hot as I can before I weld it. But it seems to me that the weld, it sticks to the 3mm tube, the wall thickness tube, but it doesn't stick to the solid bar. So I've basically pulled the whole thing apart again, buffed all the edges and surfaces and stuff, and we'll have another go. Gonna try a few more things to see if we can figure out how to get the heat to stay in that solid. So it's a little hard to see in the light, but you can sort of see down there I've got the flame right on the corner of that solid bar to try and get as much heat to soak into it as possible. This one here is the after effect. It's a pretty manky weld, but it is actually holding, so I'm starting to get enough heat into it that the weld will stick. So my plan, nice clean weld area, we're gonna soak as much heat as possible into it, and then we're gonna just start, yeah, I've got the welder set pretty much right up top, so as high as I can get it, so I can get as much heat into the weld as fast as possible. Yeah, see if we can give that a go.
It should be coming out a lot quicker the higher.
Not happening. Sounds a shitload better.
It sounds better with the lower amperage, voltage, doesn't it?
Yeah. What if we knock the wire speed up on the handle?
Yeah, it's up quite high. Might be a bit more. You're pretty pretty good stuff. Yeah.
Each of them square.
Okay.
And then that one there, again, it goes down, it should be going down square and meet up with those.
Won't you come on over? We can party till the sun's down. We're dancing and think I could go for some weekends. Hey baby, I tell you everybody's standing for the world's life. If you're coming over, we can take the roller coaster. Everybody's looking for a ride in the water slide.
You got a pair of those 4-inch grinder with the radiator pulls on? Make up a heck.
Quite hot.
Yeah, you put
Put that down.
run under the tap or something.
Yeah.
You wear your gloves, so I just pick it up.
I think. Oh, what's that note one? Now that we've got the frame built, we can go through and start cleaning up the welds. I'm going to get a flapper wheel and just basically buzz them all smooth. There's some that are a bit lumpy. It's a bit difficult to weld 25mm solid to 25mm hollow. The heat difference is obviously quite a bit between them. Malcolm's weld is a hell of a lot more powerful than mine, so it was able to buzz through and get a decent amount of heat into that solid 25mm. So the plan, we're going to go through, clean them up, and then we can start building the stainless, I don't know what you call them, cheeks, sides, something like that. We'll get those built. Right, now that we've trimmed up all of that aluminium where the welds were and so on, looks clean enough. I'll give that a bath in acid soon just so that we can make it look one colour and come up really beautiful. I need to start making the stainless side pieces. So, they're pretty straightforward. I've got some 100mm by 6mm stainless flat bar. I'm going to cut two pieces 300mm long, or what's that, 12 inches long, and then we'll weld them together, shape them up so that they're identical, and then we'll drill all the holes so that they're both a perfect match for each other. It's important that they're a perfect match, because if they're not, the hinge will start, as it goes through its travel up and down, it'll hook over to one side or it'll bind up if they're not absolutely perfect. Easiest way to make them identical is weld them together, drill all the holes, and then break the welds open. So this is the piece that we're left with. So it's basically got 3 welds in it, can't move, it's dimensionally going to be stable. We can then start rounding off the corners and everything, know that that's going to basically make 2 duplicate parts, and then we can just flat grind these and they end up disappearing and coming off, and then just a quick flapper over all the edges and you'll never even know that it was welded. What I need to do is mark in 2 holes where we're going to drill a hole the same diameter as this pin. So we'll do a 12mm hole in here. Now they're going to be 235mm apart, so we'll get that organised now. What I do need to figure out though is I have to offset them slightly, so I think the bottom one has to be out and the inside one has to be in, so I just have to figure out exactly yeah, what measurements and everything we need to do to achieve that. So we'll go and do a bit of a measure up upstairs, and then I'll come down and I'll duplicate it onto this piece of steel. There's quite a bit involved in getting this hinge done, probably twice as much as what I first thought when I started building this thing. So we're going to leave it here for this week, but I'll give you a sneak peek of how Jess found it when we finally put this thing together.
Oh my god, that is amazing!
I haven't quite figured it out yet. Isn't it cool?
Wow.
Probably the most complex hinge I could have ever built for this.
Yeah, I know.